let's understand what is this angle of repose. Let's say this is a horizontal surface and onto this surface is lying a block of mass m. There is friction between these two. Now we have to find out what is the value of coefficient of friction between these two. So what we can do is we can gradually increase the angle, and we know as we increase the angle at one value this will start sliding. Let's see what happens when we increase this angle. Suppose this is kept at angle theta. Now we have reached angle theta. Then this mg, where it is, obviously it will all the time it will be acting vertically downwards. The angle between these two intersecting lines is theta. So we are going to have the same angle between their perpendiculars. Perpendicular to this is this, perpendicular to this is this. So as a result, whatsoever is the angle between these two lines, the same is going to be angle between these two lines. Mg has a components. We have broken this mg into two components, mg cos theta and mg sin theta. Once this force is broken into components, we can remove it. Either we can have a resultant or we can have its components. So this force mg is now represented by its components. Now what we see is, if we take this as x-axis, if we take it as y-axis, so along the y-axis, mg cos theta is this way, this applies a normal reaction onto it, and this applies normal reaction, this retorts back and applies a normal reaction in this direction. It is not moving along the y-axis, so as we have done earlier, that is normal reaction is equal to mg cos theta. So mg sin theta will have a tendency to move this block in the downward direction. As a result, the friction force arises between these two surfaces. So this block, when tries to move it this way, this applies a force onto this in this direction, and this applies a friction force in this direction. Both the forces, they are equal and are opposites. Now we know that is sin theta. As the theta goes from 0 to 90 degree, the value of sin theta it increases. Whereas the value of cos theta, suppose theta is going from 0 to 90 degree, then its value of cos theta decreases. At this juncture, we cannot say that is friction force is mu into n. We cannot say that. We cannot say, generally the students they make a mistake, that is if the angle is theta, so this friction force is going to be mu into n, that is mu mg cos theta. That is a friction force, that is generally the students say. But remember, this is the limiting value. When we say mu into n, please understand this is the limiting value of friction force, this is the maximum value of friction force. As we keep on increasing the angle, when the angle is increasing, then the limiting value of friction force, because theta is increasing from 0 to 90 degree, this cos value is decreasing. So it means as we keep on increasing the angle, this mu mg cos theta limiting value of friction force that is decreasing, and mg sin theta component that is increasing. At one value, now at angle theta, the limiting value of friction force is mu mg cos theta. But what is the value of friction force? Value of friction force, it can be easily said, because over here this force is mg sin theta and this block is not moving this way. So it means this force should be equal to mg sin theta only. So over here, when this block is not moving over this, then the value of friction force is not mu mg cos theta but mg sin theta only. Obviously this force and this force, they are equal onto the block. Net force is equal to 0, so the block is stationary. Mu mg cos theta may be a bigger force. Please remember that is mu into n, that is a limiting value of friction force. At this theta, it is not moving down, so this force is equal to this force. As we keep on increasing the angle, we know that is cos theta will be reducing, that is the limiting value of friction force is gradually going down, and mg sin theta is gradually picking up, it is increasing. And at one value, when it just starts slipping down the plane, it will just start slipping down the plane, it means that is at this moment, that is downward force, mg sin theta, it comes out to be equal to mu mg cos theta. Mg sin theta has just overcome the limiting value of friction force at some theta. This theta and that theta what we are talking about is different. So at that juncture, which we call, suppose this is angle theta at which it starts slipping, it means the mg sin theta, it has become equal to the limiting value of frictional force. So at that instant, mg sin theta is equal to mu mg cos theta. If you divide this, if mg cos theta goes over here, so mu comes out to be tan theta. Mu comes out to be tan theta. Angle of repose is that angle at which the motion just begins.